Hi, this is Barb Eichinger from Future Plus Systems, and welcome back to our lab. Today we're going to talk about the DDR detective. DDR memory analysis made easy. The DDR detective provides three main functions. It checks the memory channel for adherence to the JEDEC specification. It provides general debug capability and provides advanced performance analysis. The DDR detective can analyze DDR memory channels where the memory is down on the board, using a chip interposer or a midbus footprint. It can also provide analysis for any server, laptop, or tower that uses a DIMM or SODIMM form factor. There is also the capability to provide a simultaneous connection from any DIMM or SODIMM socket to a Keysight logic analyzer. All these probing methods can be used for DDR3, LPDDR3, LPDDR4, and DDR4. So let's see the DDR detective in action on a DDR4 target. The DDR detective software runs on any attached laptop or PC. Selecting which technology you want to use is very easy. The DDR detective is very easy to set up. First, select the probing type. Then, auto-detect the frequency. A clock frequency just over 1200 means we will be running at 2,400 megatransfers per second. Next, let's run iDetector. iDetector eliminates the skew associated with the motherboard, the connector, and the probing, allowing the DDR detective to latch the address command and control correctly. This process takes 90 seconds. When it's completed, we just hit apply. In order to capture important configuration information, the DDR detective captures the mode register settings. The information is shown here and automatically fed back into the configuration of the tool. The DDR detective also captures the SPD automatically. The information is shown here. Important information from the SPD, like the speed bin parameters, are needed in the configuration of the DDR detective to detect violations and calculate latencies. Now that we're done with the setup, let's put the tool to work. Let's go to the violation setup, select all, and we can quickly see if our target is violating the JEDEC specification. The DDR detective is very unique in that it is the only tool on the market that uses thousands of counters to look for all potential JEDEC specification violations simultaneously. Well, there are several violations, and we can see that they are occurring on both ranks. Let's take a closer look at violation number 6. We'll set the trigger to violation 6. We can set the DDR detective's sophisticated store qualification to store all commands except no-ops and deselects. This makes the trace easier to read and saves trace memory. So here's violation 6 in the state listing, along with several other violations the tool has captured. The JEDEC specification specifies that commands on the bus cannot be too close together or too far apart. For violation 6, two activate commands to the same bank group can be no closer than 8 clock cycles. As we can see here, the tool indicates that the two activate commands to the same bank group are 6 clock cycles apart, not 8. Thus, a violation has occurred. The DDR detective looks for all the violations simultaneously and only stops, triggers, and traces when told to do so by the user. In addition to finding violations, the DDR detective has a full complement of general debug features, like markers, a colorful state listing, and a waveform. The state waveform is very useful. You can see all the commands, the violations, and a unique Future Plus DDR detective only, which is the power status of every rank. You can change the color scheme of the waveform. And you can even add sticky notes. This can be helpful when passing along information to your colleagues, who you can share the information with. The DDR Detective software has no licensing, so you can store the data and share information freely with your colleagues. For general debug, the DDR Detective has powerful triggering and a very large trace buffer, up to 512 meg, with pre-store and post-store. Triggering is an or an and. In addition, it can handle an external trigger. The DDR Detective is much easier to trigger than a general-purpose logic analyzer. That's because of its powerful FPGA design that takes the protocol and simplifies it. You can easily trigger by command, address, bank group, or violation, and even on the individual signals themselves. The DDR Detective has powerful store qualification. This allows you to only store in the trace buffer the commands of interest. This can be very useful when looking for patterns, like refresh intervals. The advanced store qualification allows you to store an individual command to an individual location, allowing you to find those elusive problems much faster. This advanced storage qualification is only found on the DDR Detective. The DDR Detective also has a run log. The run log indicates second by second which violation has been found and the violation count. This is very useful when trying to figure out when an error occurred over a long runtime. The DDR Detective has a charting tool. This allows users to quickly understand what has been acquired in the tool's large trace buffer. This feature allows the data to be displayed in a two-dimensional or three-dimensional fashion. Another innovation only found on the DDR Detective. The DDR Detective has advanced performance counters. Once the performance code is loaded into the onboard FPGA, the DDR Detective will be dedicated to making advanced, never-been-done-before DDR4 performance measurements. Let's quickly go through the 9 performance analysis modes and the summary and drill down modes. If you would like a more detailed explanation of these modes, see our more in-depth video on this topic. The performance counters can count complicated events and time between events for hours and even days, never missing a clock edge. These highly accurate metrics give unprecedented insight into computer memory operation. The first analysis mode is command bus utilization by rank. This covers all 24 DDR4 commands by counts per second or percentages. You could look at all the commands or just the ones of interest. Next is command bus utilization by bank. You can use this mode to identify system hotspots. Verify that the traffic is what you would expect given that the software you are running. You can look for write optimized operation and to see if any infrequent transactions are ever occurring. The next analysis mode is called page hit. The DDR Detective tracks the opening, access, and closing of all pages in the slot that it's installed in. A read hit is a read access where the page was already opened. A write hit is a write access where the page was already opened. This is the performance path. A miss is a read or write access that needed to have the page opened prior to the access. Thus, it is preceded by an activate command. Unused is where the memory controller opened the page and then closed it with no read or write access. Next is bank group analysis. In DDR4, the performance path is for back-to-back transactions to go to different bank groups. If back-to-back transactions go to the same bank group, it's a performance penalty. This mode tracks that metric for each read-write combination. Power consumption is a big issue for today's systems, and open banks burn power. With the Open Banks mode, the tool tracks how many banks are open simultaneously and for how long, for each second for all the banks being monitored. Lots of simultaneous open banks are great for performance. but bad for power management. DDR4 has several power management related commands that instruct the memory to go in and out of various power management states. The DDR detective can track all of these and tell the user when they are occurring and for how long the system remains in that state for each second. Remember, the tool can run for hours, and each second can be played back for analysis. No memory performance analysis would be complete without bandwidth analysis. This can be seen under data bus utilization. The tool breaks out each contribution by rank and bank and gives the results in raw counts of transaction type or by megabytes per second. Bank utilization tells the user how long each bank is open for each second. This is slightly different from the bank open analysis, which tells us how many simultaneous banks are open at any one time. Bank utilization can help identify system hotspots, like row hammer events. Lastly, we have bus mode analysis. This can be useful when tracking a system boot, as shown here. The memory goes through a complicated process during a boot. Understanding this can lead to faster boot times, and also figuring out why a system is not booting. The summary and drill down modes allow the user to display minutes and even hours worth of detailed information on one screen. Where the previous modes graphed second by second, this summary mode aggregates that information into one timeline. This never been done before analysis gives users that holy grail of near continuous trace, allowing entire system benchmarks to run and memory performance analyzed. Well, that's it for our quick overview of the DDR detective. Let's recap the advantages of this tool. It can be used for general debug with its deep trace, triggering, storage qualification, waveform, and state listing. It can be used to look for hundreds of JEDEC specification violations simultaneously. Lastly, the tool can be used to perform detailed performance and power management analysis. This tool can be used for DDR4, DDR3, LPDDR4, and LPDDR3 with a variety of probing options. Thanks for joining us today. For more information, contact us at protocol.decode@futureplus.com or check out our DDR Detective website or our main product website. And we'll see you next time in the lab.